Hi students, in this video I'll be going through the chain rule for differentiation. So I'll first go through how the chain rule works, and then after that we will try some practice questions, alright? So for the practice questions, you might want to pause the video and try the questions on your own first before continuing to watch the video to review your answers, alright? Right, so let me use this example to explain how the chain rule works. So let's say you're asked to find the derivative of this function y equals to 3x minus 2 to the power of 5. Okay, so previously when we first started our discussion on differentiation, so let's say we have a function like this, y equals to 3x to the power of 5, right? So if it's just like this, then when we differentiate, okay, so remember the rule is that to bring the power in front. Okay, so if you bring the 5 in front, then it multiplies with the 3 to become 15. Then what we'll do is reduce the power of x by 1. Okay, so if we have a simple function like y equals to 3x to the power of 5, then it's very easy to differentiate, right? Okay, but in this case, if you look at this question, we have 3x minus 2, we have actually two terms inside, 3x and then the minus 2, the whole thing to the power of 5. Okay, so if you are thinking maybe we can use a binomial theorem to open up the full thing and then differentiate each of the terms separately, right, to get the derivative, then that's going to take quite some steps now, okay? Okay, so in this case for functions like this, we will need to apply something called the chain rule. Okay, but first let us understand how the chain rule works. Okay, so because there's more than one term to the power of 5, right? Inside the bracket there's more than one term, right? Okay, so what we usually do is that we can let u be equals to the term that is inside the bracket. Okay, so let's say u is now 3x minus 2. Okay, then the function will become y equals to u to the power of 5. Okay, so if you relate this to this, okay, it looks very similar, right? Okay, it's just y equals to something to the power of 5, right? Okay, so from here, what we can do to differentiate is that we can do dy du. Okay, so if it's y equals to x power 5, then it's dy dx. Okay, differentiating y with respect to x, but now it's u on the right side, right? So we do dy du. So dy du will be very simple. Just bring the power in front and reduce the power by 1. So this is dy du. Okay, but remember, at the end of the day, they want us to find the derivative of y equals to 3x minus 2 to the power of 5. So on the right side is x, right? So in the end of the day, what they want us to find is actually dy over dx. Okay, but now what we have found is dy over du. Okay, so what we have found is dy over du. Okay, so now what we are going to do is we are going to ask ourselves, dy over du times what will give me dy over dx? Okay, so apparently we need to get rid of this du, right? So what we can do to get rid of du is to do times du over dx. So if we times du over dx, you see, we can actually cancel away uh, the du and you will get dy over dx, alright? Okay, so what we will need now is du over dx, okay? We have already done dy over du, and dy over du is over here, 5u to the power of 4. So now we need to do du over dx. Okay, so remember what did we let u be? U is 3x minus 2, right? So if u is 3x minus 2, okay, then du over dx is just going to be, okay, differentiate 3x minus 2, you're just going to get 3, right? Okay, so in other words, what we have now is dy over du, which is 5u4 times du over dx, which is 3. Okay, so now I'm going to replace the u back with this function, okay? Because the final answer needs to be in terms of x, right? So we'll get 3x minus 2 to the power of 4 times 3. So this will give us 15, 3x minus 2 to the power of 4. Alright, so this will be the final answer for dy over dx. Okay, so let's study this mechanics and see how we can get the answer more directly. So over here we have, remember the starting equation is 3x minus 2 to the power of 5, right? Okay, so let's compare with what we have done over here, the derivation. Okay, what happened? Okay, you see the final, okay, let's focus on this line. Okay, so we have y equals to 3x minus 2 to the power of 5. Okay, now the 5 is in front, right? So basically what we have done is we work as per normal, okay? If you differentiate, you bring the 5 in front. Okay, the power goes in front. Okay, what happens to the power? Now become 4, right? Okay, so you reduce the power by 1, so 5 minus 1. And then where did this extra 3 come from? Okay, this extra 3 came from differentiating 3x minus 2, right? Correct or not? So basically, the extra step that you need to do for chain rule is to differentiate inside the bracket, okay, and then multiply. Okay, so basically differentiate whatever is inside the bracket. So in this case, what 3x minus 2 is inside the bracket, right? You differentiate 3x minus 2, you get 3, and then you just multiply behind. Okay, so the mechanics of chain rule is very simple. I repeat again now. Okay, just bring the power in front as per normal, reduce the whole power by 1, and then after that, the extra step you need to do is differentiate whatever is inside the bracket and multiply it behind. All right, and multiply it behind. Okay, so you end up with 15, 3x minus 2 to the power of 4. Right, so this is a very simple example with regards to the chain rule. Right, so this is how the chain rule works. Okay, so let's now try some practice questions. Okay, so you can pause the video and try the questions. Okay, then after that, continue playing the video and then you review your answers. All right. Okay, so differentiate each of the following with respect to x. So we start off with some simple questions, right? So d over dx. So you have 2x minus 1 to the power of 6. Okay, so the mechanics is the power goes in front, reduced by 1, so 6 becomes 5, and then you differentiate inside the bracket. So if you differentiate 2x minus 1, then you end up with 2, right? So you multiply the 2 behind, right? So this is how the chain rule works, right? So this will be the answer. Okay, so it's not difficult at all. Right, the next one is 1 over 3x minus 2. So we need to prepare this function to a form that is suitable for differentiation. So what we will do is we will write it as 3x minus 2 to the power of negative 1. Okay, and then this is what we're going to differentiate, right? Okay, so same thing, bring the power in front. So the negative 1 goes in front. So negative 1, we just write negative, all right? 3x minus 2. Okay, we'll reduce the power by 1. So this be careful. Negative 1, you minus another 1 becomes negative 2, right? And now we differentiate inside the bracket, we'll get a 3, right? So if you differentiate 3x minus 2, you get a 3. So multiply it behind, right? Okay, so the answer will just be this. Okay, so we want to return it to the positive index form, so it becomes 3x minus 2 squared. Right, so I hope at this point in time you're starting to get the hang of it. All right. Okay, let's now look at the next question. Okay, so same thing, prepare for a form suitable for differentiation. So you get 2, 5x minus 1 to the power of negative 2. Right? All right, so let's differentiate this. Okay, so 2 here. Okay, let's put a square bracket for this. Five x minus 1 to the power negative 2. Okay, so the power goes in front. Okay, there's already a 2 in front. So if your negative 2 goes in front, 2 times negative 2, okay, will give you negative 4. Right, then you have 5x minus 1. Reduce the power by 1, so become negative 3. Differentiate inside the bracket, you will get a 5. So you multiply over here. So answer will be negative 20. 5x minus 1 to the power of negative 3. Okay, so this is the answer that you will get. Okay, so okay, maybe let me write one extra step over here. Okay, 5x minus 1 cube. Okay, so this should be cube. Okay, there should not be a square root. Right, so this will be the final answer already. Right. Right, so as you can see, it's actually not too difficult to apply the chain rule. Right, let's look at this next one. So same thing, let's prepare for form suitable for differentiation. So square root is power half, right? Okay, square root is power half. So you differentiate 6x minus 1 to the power of half. Okay, so bring the power in front. So half goes in front. So 6x minus 1. Okay, power half minus 1, right? So we'll write an extra step. Differentiate inside the bracket, you get a 6. Okay, so the half times the 6 will give you a 3. Okay, so half times this 6, okay, multiply together to get the 3, So 6x minus 1. Okay, power half minus 1 becomes the negative half. Right, so if you bring down, you end up with 6x minus 1 to the power of half. Right, then you will get 3 over square root 6x minus 1. Right? Right, let's try this next question. All right, cube root will be power 1/3 if you recall. So 5x minus 2 to the power of 1/3. Right, so put it in a form suitable for differentiation. We put in this form. Okay, then we can start differentiating. Okay, so over here, right? And okay, so power goes in front, so 1/3 goes in front. Okay, reduce the power by 1, so 1/3 minus 1. Right, so for this question, I'll just write an extra step, okay, so that we can be clearer about the working. Okay, then differentiate inside, you get 5. So over here, you will get a 5 over 3. 5x minus 2. 1/3 minus 1 will give you a negative 2/3, right? Okay. 1/3 minus. Oh, sorry. Over here is a negative 1/3. Okay. Okay, so let me redo this question, alright? Okay, let me redo this question. Okay, so this is a negative 1/3. Right, so when we differentiate, we bring the negative 1/3 in front. Okay, so 5x minus 2. Okay, negative 1/3 minus 1. Right, so this will be correct one. Okay, then you differentiate inside, you get 5, so you get this, right? Okay, so negative 5 over 3. Okay, this one you get 5x minus 2. Negative 1/3 minus another 1, you get negative 4 over 3, right? Okay, so we'll bring down and make it the positive index. So the 5 remain on top, the 3 is at the bottom, right? So you get 5x minus 2 to the power of 4 over 3. Okay, so we'll return it to the square root form as for the final answer. So 5 over 3. Okay, let me simplify, convert this one at the side for you to see. So for this kind of question, okay, where the power is a fraction, okay, basically we can always split up into like that. 5x minus 2 to the power of 4, and then the 1/3 is outside, right? So 4 times 1/3 will give you the 4 over 3. Okay, so this means that this function is actually cube root of 5x minus 2 to the power of 4. Right, so this is how I get the answer from here. Cube root of 5x minus 2 to the power of 4. Okay. Right, let's take a look at 2 more questions which are slightly different. Okay, so in this question, now they give you this function y equals to 2x plus 5 squared times square root 2x plus 5, right? Okay, so obviously in this form, it's not ready for the direct chain rule application. But you should notice that both are 2x plus 5 terms, right? So what we can do is that we can use the law of indices to combine them together first. Okay, so square root is power half. Okay, so if you combine them with the law of indices, same base, both the base are 2x plus 5. So you combine them together, you get 5 over 2. So this will be a suitable form for differentiation now. Okay, so if they give you y equals to the function, then the presentation is to write dy dx. So the 5/2 comes in front. Okay, so 2x plus 5. Okay, reduce 5/2 by 1, you will get 3/2. Okay, then differentiate inside a bracket, you will get 2. Okay. Okay, 5/2 times 2, so multiply these two numbers together. Okay, you will just get a 5. Okay, then for this 2x plus 5, 3/2. Okay, if you recall, it's just a square root form will be the cube inside, all right? 2x plus 5 cube. Okay, the top one is always the power here. And then the bottom one will be the root, right? Okay, so this will be the final answer already. Okay, let's do one last question. Okay, so now we are given this function. Okay, you should realize that the base is the same. Okay, which means that we can just add up the numerator to get this. Okay, then you will notice that both are 2x plus 1 terms. So we can actually combine them using the law of indices first. So this is actually 2x plus 1 to the power of half. So if you divide power 1 over power half, you subtract the power, right? So you end up with 2x plus 1 to the power of half. Okay, so this is what we will differentiate. Okay, bring the power in front. Reduce it by 1. So half minus 1, you get negative half. Differentiate inside, you will get 2, right? So half times 2 will just become a 1, right? Okay, so essentially you are just left with this term over here. So we're going to return it, change it to positive index. Okay, and then return it to the square root form. Okay, so it'll just be like this. Alright, so the chain rule, not too difficult to apply. Okay, maybe I can just try one more question and see. Okay, so what if we have a question like this, alright? So let me add in one more question. So y equals to maybe x squared plus 3 squared over square root x squared plus 3. Right, so same thing, we're going to use the law of indices, okay, combine them together first. Okay, so x squared plus 3 squared. Okay, the bottom is just a power half, right? Alright. So power 2 over power half will be power 1.5, 3/2. So this one will become x squared plus 3/2. So inside the bracket now, you see you have an x squared term. Okay, but it doesn't matter. We apply the chain rule. You just apply what we have been doing all the while. Okay, power come in front. Okay, then reduce it by 1. So 3/2 minus 1 becomes a half. Okay, now if you differentiate inside of the bracket, x squared plus 3, you end up with 2x, right? So it doesn't matter, just multiply the 2x behind. So it works the same way, right? Then 3/2 times the 2x will just leave you with 3x. Okay, so x squared plus 3 power half, still there. Okay, then just return it to the square root form. Right, so I hope that this video on chain rule has been able to help you to understand and be able to apply the chain rule confidently. Okay, so basically a chain rule is just normal differentiation with one extra step behind, which is to differentiate inside the bracket and then multiply the derivative behind, right? Okay, so the next video I'll be doing will be on the product rule. Okay, but it'll be good to master the chain rule first before you do the product rule, because sometimes for product rule, within the product rule itself, you need to apply the chain rule as well.